Welcome to this tutorial on Python list comprehension. List comprehension is a powerful and elegant way to create lists in Python. It offers a concise syntax to generate new lists based on existing iterables. In this video, you will learn how to use list comprehensions to write more efficient and readable code. Let's compare the traditional approach of creating a list using a for loop with the list comprehension method. On the left, you'll see a function called createSquaresTraditional. This function initializes an empty list called squares. It then iterates through the numbers 0 to 9 using a for loop and the range function. Inside the loop, it calculates the square of each number and appends it to the squares list. Finally, the function returns the squares list. On the right, we have the list comprehension way of doing it. See how createSquares comprehension function returns a list created in just one line. It calculates the square of each number, I for I in the range of 0 to 9. Both methods give the same result, but list comprehension offers a more compact and readable syntax. Notice how much cleaner and easier to read the list comprehension method is. Let's break down the basic syntax of list comprehension. The structure is as follows. Square brackets containing an expression, followed by a for keyword, then a variable name, followed by the in keyword, and finally an iterable. The expression is what will be evaluated for each item in the iterable. The item is a variable representing each element in the iterable as you loop through it, and the iterable is any collection of items like a list, tuple, or range. Here are some examples to illustrate this. First, to create a list of squared numbers, we write x times x for x in the range of 5. This will generate the list 0, 1, 4, 9, and 16. Next, to create a list of greetings, we use an f-string, f-hello, name, for name and a list of names like Alice, Bob, and Charlie. This will give us the list hello Alice, hello Bob, and hello Charlie. List comprehensions can also include conditions to filter elements or modify values based on certain criteria. The syntax for conditional list comprehension comes in two primary forms. The first is expression for item and iterable if condition. Only items that meet the specified condition will be included in the new list. The second form is expression 1 if condition else expression 2 for item and iterable. This allows you to apply different expressions based on whether the condition is met. Here are a couple of examples. To filter only even numbers from 0 to 9, we write x for x in the range of 10 if x modulo 2 equals 0. This gives the list 0, 2, 4, 6, and 8. For conditional values, let's replace odd numbers with the string odd. We write x if x modulo 2 equals 0 else odd for x in the range of 5. This results in the list 0, odd 2, odd, and 4. Nested list comprehensions allow you to create lists within lists, which is particularly useful when dealing with multidimensional data like matrices. Here are two examples. First, flattening a matrix. Suppose we have a two-dimensional matrix that is a list of lists. To flatten this into a one-dimensional list, we write number for row in matrix for number in row. This will unpack each row and then each number within the row, creating a single list of all numbers. Second, creating a matrix. To create a 3 by 3 matrix where each element is I times j, we write a nested comprehension. The outer loop iterates through I from 1 to 3, and the inner loop iterates through j from 1 to 3, calculating their product. List comprehensions offer significant performance benefits compared to traditional loops. List comprehensions are generally faster and more memory efficient. The primary reasons are that they are often executed at the C language level, expressions are evaluated once per element, and there is no need for intermediate variables. Here are a couple of benchmarks. Creating a list of 1 million items takes about 152 milliseconds using a for loop, while the list comprehension only takes 89 milliseconds. Filtering 1 million items takes 210 milliseconds with a for loop, whereas it only takes 110 milliseconds using list comprehension. In summary, list comprehensions provide advantages such as more memory efficiency, faster execution, expression evaluation once per element, no need for intermediate variables, and optimized iteration over sequences. List comprehensions can often replace other functional methods like map and filter, offering a more readable and concise alternative. Let's look at how list comprehensions compare to map and filter. Using map with lambda, we can square a range of numbers by writing map, lambda x, x times x, and the range of 10. The equivalent list comprehension is simply x times x for x in the range of 10. Using filter with lambda, we can filter even numbers by writing filter, lambda x, x modulo 2 equals 0, and the range of 10. The list comprehension version is x for x in the range of 10 if x modulo 2 equals 0. Generator expressions are similar to list comprehensions, but use parentheses instead of square brackets. They generate values on the fly, which can be more memory efficient for large datasets. Dictionary comprehensions extend the same concept to create dictionaries, using curly braces and key-value pairs. List comprehensions are incredibly versatile and can be applied to a variety of real-world tasks. Let's consider some examples. They can be used for data cleaning. To convert strings to integers and remove errors, you can write a list comprehension that parses data while ignoring non-numeric values. In file processing, you can extract all Python files from a directory using a list comprehension with a conditional that checks for the th extension. They are also helpful in data transformation. Convert Celsius temperatures to Fahrenheit using a simple formula inside a list comprehension. Also, in web development, you can parse query parameters from URLs, extracting key-value pairs into a dictionary. To make the most of list comprehensions, it's important to follow some best practices. Let's consider the do's and don'ts. First, do keep comprehensions simple and readable. Add comments for complex logic. Use meaningful variable names. Consider using generator expressions for large datasets. Split complex operations into multiple steps. Now for what not to do. Don't nest too many levels of comprehensions. Don't use comprehensions for complex logic with side effects. Don't write overly long expressions in a single line. Don't sacrifice readability for compactness. Don't use comprehensions when a simple loop would be clearer. In summary, list comprehensions provide a concise way to create lists in Python. The syntax is bracket expression for item and iterable if condition bracket. They are more readable and often more efficient than loops. You can include conditions for filtering elements, and they support nested iterations for more complex transformations. Remember related concepts like dictionary comprehensions and generator expressions. Always keep it simple and readable for maintainable code. This concludes our tutorial on Python list comprehension. Thank you for watching. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.